So in this problem, we are provided with the equation of a parabola, and we need to determine its coordinates of the vertex and the focus, equation of the x-axis and the directrix, as well as the length of the lattice rectum. Let us begin. So we'll start with the given equation of the parabola. So here we have y squared minus 4y minus 3x plus 1 equals to 0. So that can be also rewritten as y squared minus 4y. We're going to transpose negative 3x plus 1 to the right hand side, giving us 3x minus 1. In the next step, we'll try to convert y squared minus 4y into a perfect square. All we have to do is rewrite the second term as a multiply of 2, so that we get 2 times y times 2. And this number 2 is going to tell us that we need to add square of that number, and that's an extra number that we're adding from our side, so we need to subtract it as well. We get negative 2 squared. This will be equals to 3x minus 1. Now the first three terms, that's nothing but y minus 2 whole square. So we have negative 2 squared, that's negative 4. So we're going to transpose negative 2 squared to the right hand side and combine with negative 1 to get positive 3. So we have 3x plus 3. Now we're going to take 3 as the common factor on the right hand side. So we have 3 times x plus 1. Now this is a equation of a parabola written in its standard form. However, its vertex has been shifted from the origin. Now what we'll do, we're going to change the coordinate system. So from x comma y, that's the old coordinate system, we're going to go to a new coordinate system by considering y minus 2 to be equivalent to y in uppercase and x plus 1 to be equals to x in uppercase as well. So that means our equation 1 is now going to transform into y squared equals to 3x, and this has a familiar form with y squared equals to 4ax. That means if we compare with the standard form y squared equals to 4ax, we get the value of 4a equals to 3. Or we can say that a comes out to be 3 over 4. We're going to use this value. Now let's try to understand the graph of the parabola y squared equals to 4ax. So here we have the graph of y squared equals to 4ax with the value of a as 3 over 4. So that means if we substitute a with 3 over 4, then this graph is going to be y squared equals to 3x. So that's the equation that we obtain. Now the vertex of this particular parabola y squared equals to 3x will be at the origin 0, 0. The coordinates of the focus will be at a, 0. Since a is 3 over 4, that means the coordinates of the focus will be 3 over 4, 0. Then we have the axis of symmetry line. This is the line on which the focus and the vertex of the parabola lie. So since it is lying on the x-axis, so its equation will be given by y equals to 0. Then we have the directrix. The directrix is passing through the point x equals to negative a. That's why its equation will be x equals to negative a. And then we have the lattice rectum. It's the straight line which passes through the focus and perpendicular to the axis of symmetry with its endpoints touching the parabola. It has a length given by absolute value of 4 times a, and now substituting a with 3 over 4, this will be equals to 3 units. Okay, now this particular parabola has been expressed in terms of the new coordinates x, y. We have to go to the old coordinate. All we have to do is wherever we find x, we'll be substituting with x plus 1, and in place of y, we'll be replacing with y minus 2. Let us begin. So we'll start with the vertex. Now the coordinates of the vertex according to the new coordinate system will be at 0, 0. Which means that the x value equals to 0 and the y value corresponds to 0. But in place of x, we're going to replace with x plus 1 and the value of y with y minus 2. Which means that we have x plus 1 equals to 0 and y minus 2 equals to 0. So solving for x and y, we're going to get x equals to negative 1 and y will be equals to positive 2, which means that the coordinates of the vertex is going to be negative 1, 2 according to the old coordinate system or the original coordinate system. Okay, moving on to the focus. So our focus is at the coordinates 3 over 4, 0. So that means our x value is corresponding to 3 over 4 and the y value corresponds to 0. So in place of x, we're going to replace it with x plus 1. So we have x plus 1 equals to 3 over 4. which means solving for x, we're going to get 3 over 4 minus 1, so that's negative 1 over 4. And then we have the y value equals to 0. So in place of y, we're going to replace with y minus 2. That will be equals to 0, giving us y equals to 2. So that means the coordinate of the focus according to the original coordinate system will be negative 1 over 4 comma 2. Now coming to the equation of the, let's consider the equation of the axis. Now, according to the old coordinate system, in place of y, we're going to replace with y minus 2 equals to 0. That gives us y equals to 2. So this is going to be the equation of the axis. Then let's come to the equation of the directrix. The equation of the directrix, we obtained it as x equals to negative a. So a is 3 over 4. And we're going to replace the value of x with x plus 1. So x plus 1 will be equals to negative 3 over 4, which gives the equation x as negative 7 over 4. This is going to be the equation of the directrix. And finally, coming to the length of the lattice rectum, the length of the lattice rectum, that's going to be equals to absolute value of 4 times a, and we have already defined that when we substitute a with 3 over 4, we get it as 3 units. The meaning that this is not dependent on the coordinate system. The length of the lattice rectum is going to stay independent of the coordinate system. So its length is always going to be 3, whether we measure it from the new coordinate system or with respect to the old coordinate system, because the length of the lattice rectum talks about the shape of the parabola. So the shape of the parabola remains unchanged in both the two coordinate system.